Okay, here's the solutions to 13 and 14. Pause if you need time to take a look. Okay, so we're just going to wrap up here with this application problem of exponential functions. Investment problems are exponential. So basically, all investments over time, they go up and down, but if I were to generalize this or it stayed steady, the amounts starts to kind of do this. It's not a linear increase. It's going to go up exponentially if the rate remains the same. Okay? All right, so there's some formulas here you don't need to memorize. You just have to know how to use them. So some key things you got to understand. T is always the years. Maybe you want to highlight some of the variables. T is going to represent years. A is the amount or the balance in the account. Principal is going to be P, capital P. The interest rate is R. And then N is going to be the number of times it's compounded. You only put that down here, compounded N. We should probably write it up here. So N is the number of times it's compounded per year. Number of times it's compounded per year. Basically, banks and investments give you options. They can compound or calculate the interest every each month, maybe quarterly, which means every 3 months. They can change the amount of times that they calculate the interest. It's usually to your advantage if you're the person doing the investment. But that's the idea of the number of times compounded per year. Okay. All right, so complete the table by finding the balance of A when the principal dollars, they're giving us P, they're giving us the rate, and they're giving us the time. It's compounded N times per year. Okay. All right, so sometimes they'll actually use words for these. So once you add this in here too, if it's just one time, they may say the word yearly. If it's twice per year, it's going to be, they'll say semi-annually. I guess yearly, they could say annually, once a year. So semi-annually, if it's 4 times a year, this is called quarterly. 12 times a year, monthly. Or they may say it's compounded daily. Okay, so these are kind of your N values. If it says continuous, means over and over and over again, you think it'd just take right off, but it kind of levels out. And so it's a whole new formula. So if they say continuous compounding, we got to use this one. So I'll even write that formula right above it so you know that this is just different. When you see that word, we use the PERT formula, sometimes called. Principal base ERT. Okay. Okay, so here we go. I'll get this started with the first couple and then let you try. So yearly, it's filling everything that we have right here using this formula. So the amounts will be equal to, the formula says P, what's the principal? $300. Then it says 1 plus R over N. So 1 plus the rates. You got to put the rate in decimal form. So we're going to write that as 0.04, right? Take it, move it 2 spots over to the left. So 0.04. And then on the bottom, it's N. N is the number of times it's compounded per year. So right now, N is 1. Okay. Then raised to the NT. And then the exponent is going to be NT. So up here, I need N times the number of years, 8. So just collecting the variables, putting it in the right spot with that formula, okay? All right, you don't get too fancy with the order of operations. Technically, we need to start inside the parentheses. Then we do exponents, and we'd multiply, right? But these calculators can handle that for you. If you don't have one of these calculators, I guess that's what you need to do. Take that path, okay? But once we get it typed in once, it's going to shorten our work for the next few spots. So what do we have here? We got 300 parentheses 1 plus 0.04. I know divided by 1 is 0.04, but I'm going to hit divided by 1 just so that I can type over it for the next one. Raised to And if it didn't put it up there, you probably want to put parentheses around your exponent just to be safe too. I don't technically need it, but I'm going to do it anyways. Okay, hit enter, and it's that simple. That's the amount. That's not the interest. I don't add 410 to the 300. This is designed to give you the amounts. We always round to the nearest penny for these. So the 0 keeps it at 57 cents. So the amounts is 410.57. Okay. Semi-annually, all I'm going to do now is hit second enter, and where does the end value change? 2 spots, right? Here and here. Okay, so for this one, I'm not going to keep doing this because we just do this in our calculator. So this is n equals 2. We just do 300 times 1 plus 0.04 over 2 raised to the 2 times 8. Okay, so just change it at 2 spots. So I hit second enter to bring back what I just did. Type over the end value and hit enter. It's going to be a lot quicker, right? So 411.84 cents. Okay, keep going, try these, and then if you feel confident, try the PERT formula. But after you do this, I'll help you finish the continuous part, okay? Go ahead. Okay, so if you keep in second enter, 412 and 365, I just keep changing these, and I change that end value from 2 to 12, right, or 4, and same thing up there. Just follow the formula, and then these values should be exactly what we all get to the nearest penny. Try to round correctly. Look to that third digit of decimal to make a decision on the second one. Okay, and then the last one is the PERT. So on paper, this is what it looks like. It says continuously compounded PERT. And then throw it all in the calculator just like that. And we get $413.14. Okay. All right, so we'll use the next page as some warm-ups tomorrow, but we're going to stop there today. Those of you at home, though, I will show you 16 and 17 for you to do as well, so you need to know how to do those. All right, you guys can try example 16 and 17. Pause now and give it a shot, and then I'll show you the answers. When they say quarterly, change that to 4. When they said just yearly, that's annually, 1. Continuously, we need the other formula. So there's the 3 values. Here's 17, just a different exponential problem. We've got to just read for understanding. It says initial amount, that means no time has passed. So you plug it in, do the math, we get 10 pounds. You plug in these different times, these are the amounts you get. And then here's what you could get, the table values. Looks something like that. Okay, that's the end of 3.